Hello and welcome. Next topic of this tutorial is the technical parameters for product selection. The largest of the boxes is probably the most important one with regards to product selection and the hydraulic circuit calculation. So we need to be aware of what we put in here, and we may need to make sure that we have our parameters set correctly. Let's take it step by step, and we'll move down through the technical parameters just to make sure we're clear about what you need to set these to for your own specifications. The first section here is the general parameters. Here we have some options around the way HySelect will display the valves in hydraulic schemes. When the valves are actually displayed graphically on the screen, you can choose between looking at standard HVAC symbol or indeed small line drawings of the products themselves. So if you're interested in visually clarifying the product that's been selected, I would suggest that you leave this in the default selection, which is the IMI Hydronic Engineering product images. The localized HVAC symbols are for some specific markets like Austria, but if my information is correct, it's not being used actually anymore. The HySelect software itself can select all of the product ranges within IMI, and so this includes the pressure, maintenance and water quality products, thermostatic products as well as the traditional TA balancing and control products. So in here you can also preset your parameters for pressure maintenance. We'll cover this in another video because I think if you're using it specifically, we need to take a specific look at that. So you can leave the pressure maintenance settings as they are for the time being. And if you got a specific water hardness in your area and you want to set that specification, you can set it here. For balancing valves, we can set the desired minimum and maximum pressure drops. This will be of use when selecting an STAD or STF, for instance. We are suggesting to have a minimum pressure drop of 3 kPa or 1 kPa up to a maximum pressure drop of 200 kPa. You can set this to your own design specifications and even change them sometimes, but traditionally between 3 and 200 kPa is a very reasonable place to start with for your product selections. Now on the control valve parameters, when we're calculating the minimum authorities for a constant and a variable flow system, you might want to have a difference. And this is a minimum target authority for variable flow system. So traditionally, where you would have a two-port valve arrangement, where industry's generally accepted value is around 0.25 as the minimum specification, but I think that it is possible to maintain 0.5 as authority, without technical compromise, without commercial compromise. Now these are the pressure drops for the control valves. The minimum pressure drops that we want to set in our control valve as we do the product selection. So where we have a minimum differential pressure for on-off control, we are suggesting 3 kPa. We're picking it as a number just to have an absolute figure to start from. So again, you could have that as 1 kPa, 2 kPa, 3 kPa, whatever you choose. Where you've got the DP control with a proportional controller, it's going to be slightly higher. We are trying to stabilize our control valve authority here. So we're trying to make something a little bit more technical competent in this point, and we're saying you should have a minimum of 10 kPa. That could be slightly lower depending on the product itself. When you make your selections for all your products here, although these are the parameters that it's going to work off, you're going to see some outputs that allow you still to make a selection. It's not the definitive choice. It's still going to give you a range of figures on the screen that you can choose from. So these don't have to be so extremely accurate that it's not going to give you anything else but these figures. And clearly, if there's a maximum delta P that you want for proportional control to prevent excessive velocity or noise in valves, you can set 65 as a reasonable number. And again, you can always come back and fine-tune that if you find the product selections aren't looking the way that they should be. These two additional selection boxes here allow you to refine a little bit your control valve selection. With this checkbox, the KVS values are going to be based from the Renard series. So it's going to ignore anything that may be in between a traditional Renard series in terms of KV of the valve. So you can refine or reduce the total amount of options by selecting this one. The use of P-band of the P controller when sizing control valve. Now what does this mean? When we're looking at the hydraulic network and we're making selections, there is a degree of variance in delta P when using a delta P controller. This variance will have an effect on authority of the control valve. Now by selecting this, it makes our selections a little more refined because it says, please take into account the P-band of the delta P controller when sizing a control valve. In other words, please take into account the variation in differential pressure to give me my minimum authority rather than just the defined pressure drop of that circuit that is going to be maintained by the delta P controller and selecting the authority based on that. So this way you are being very accurate in terms of the minimum authority that you're going to get from your DP controller and your control valve combination. Pressure independent balancing and control valves. This one is relatively simple. This is a pressure independent balancing and control valve, or PIBCV. And all we really ask for here is, what is the minimum pressure drop for the fully open DP control part? In other words, what's the minimum amount of pressure that we want to have across that, and it will have an effect on the rate of response of the delta P control component within the valve. Again, it is very much a refinement thing. If you are looking to be super accurate, you could make this a little bit higher. Typically, I normally keep mine around about 1 kPa. And if you have a PICV that doesn't satisfy this, you can choose to hide these PICVs as they come up in your selection panel. Smart control valves and smart differential pressure control valves. For smart control valves and smart differential pressure control valves, the only parameter we need to set is the maximum dP min for best smart control valve suggestion. So this would be the pressure drop at nominal flow and KVS. A higher figure here would implement a higher dP, so potentially higher needed pump head. A lower figure would lead to oversizing the valve and not fitting commercially. So 20 kPa is a good value to start from. Delta P controllers. A minimum pressure drop of fully open delta P controllers. Again, we can use this to select a refinement of our delta P controller, and in this instance I've got mine set for 5 kPa. So we've got a minimum delta P in the fully open position for the delta P controller of 5 kPa. As you move this number up and down, clearly it will have an effect on the sizing of the valve. We can choose to hide delta P controllers that don't satisfy this limit. Again, I have mine unticked. I tend to find that I'd rather have all of the information up on the screen in front of me as part of the selection process to refine my own selections to suit my circumstance. This checkbox suggests measuring valves with the same size as the P controller only. This is for when a partner valve comes up for an STAP, for instance, and it allows us to make sure that that valve is the same size as the delta P controller. So we're not having two different kinds of valves, one on supply and one on return that are other nominal dimensions. It's typically installers that would prefer to have two valves of the same size. It usually may have a small impact on head pressure, it may have a small impact on cost, but I think for ease of installation from an installer's point of view, they much prefer to have two valves of the same size. It makes a lot more sense for them. So typically, I would have this one selected most of the time. Fixed orifices. If you're in a country that uses fixed orifice valves like MDFO or a Venturi type valve with STAV, you can set these minimum and maximum signal again based on kV. Radiator valves. Default available differential pressure for radiator valves. So when we're doing a hydraulic network calculation, we can use these checkboxes to define what our standard operation conditions are for a system and what our standard internal design temperatures are. So typically in Belgium, for instance, they would have a 70°C flow with a default room temperature between 18 and 21 degrees Celsius. So we take 21 and the default available differential pressure, in other words, the minimum available differential pressure that we would have at any given point in the system would be around 10 kPa, which is quite normal on a domestic system, for instance. Pipes. This is quite an important one. We have here a target linear pressure drop. Now this should be your ideal design, what will vary from country to country. For instance, in Scandinavia, they might design 250 pascals per meter. And you stretch as far away as Australia, and they might be anywhere between 400 and 800 pascals per meter of linear pressure drop. As HySelect is taking into account the pipeline sizing as well, this is going to have an effect on the valve sizing, but also the pipe selections that come up within HySelect. So be relatively refined with what you're looking for here, and typically I operate in a range of 150 to 250 pascals per meter. You have a selection here that allows you to take into account a water velocity. Now bear in mind, when we're sizing pipework up to a certain point, it makes complete sense to size by linear pressure drop. But when you get at a certain point around about DN 250, what you will find is that actually we really should be sizing on maximum water velocity in the pipework rather than linear pressure drop. So we can also use this to set target linear water velocities and say perhaps you want to have a maximum water velocity of 3 meters per second. So it's a pretty useful way of making sure that all your pipe parameters are correct. Because when sizing, it's quite a common mistake for people to continue sizing all the way up through the pipe range just using a linear pressure drop and not necessarily taking note of the water velocity. Because once the nominal dimension of the pipe starts to get larger, the velocity tends to increase much more rapidly than a linear pressure drop. Last in this section is the device sizes. And this is just a way of refining the total amount of product that is shown on a selection. So you can choose to have a product selected that is only the same as the pipe size. So in other words, if you specified a pressure loss between 150 and 250 pascals per meter, it's going to ensure that any valve selected fits in this restriction. Or alternatively, you can choose to select above and below. In other words, I might want to select valves that are 2 sizes above the pipe size and valves that are 2 sizes below the pipe size. The reason for this is relatively simple. When you see an output coming up in your screen here with selection of valves, or you would have a refined selection to a point where you have virtually no valves that are over or below the pipe size, or perhaps you do want to see ones that are below the pipe size for commercial reasons, or above the pipe size for energy saving reasons. So this is the conclusion of the technical parameters for product selection. A really important topic to make a proper selection in HySelect. As homework, please look at all these possibilities step by step, try to understand them and set them to your desired presets. The next video will be on the last boxes of the home ribbon. Options and information. See you soon!